In the current era of the rapid evolution of technology, we may be approaching an age of synthetic abundance. Synthetic abundance refers to an evolutionary state where human ingenuity, and rapidly advancing technologies, will be able to create plentiful supply of materials, resources and solutions, by mimicking or replacing natural processes. In essence, it's about achieving high availability, or abundance, through artificial or synthetic means, whether through industrial production or controlled synthesis processes. With the possibility of goods and services becoming so abundant, it is feasible to envision that the cost of the materials may become extremely inexpensive, or could even conceivably become free. To better explain the synthetic abundance concept, and how it pertains to our Recovery 2.0 system, we wish to focus on three key areas in greater detail. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials, in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. Today, the three areas in which we will explore the effects of synthetic abundance are energy, elemental matter, and information. The first area we will discuss is energy abundance. Energy abundance is a concept that envisions a future with access to extremely low cost and virtually limitless energy. With the development of wireless energy transfer, energy may become truly ubiquitous. Traditional industrial processes can be energy intensive, so the result of synthetic abundance is to use renewable or recovered energy as a solution to fulfill these energy demands, creating the possibility for a more sustainable and environmentally friendly future. This may be achieved through renewable energy sources such as solar and wind, or through the regenerative cycles such as carbon capture, which pulls CO2 emissions from the atmosphere for production of carbon-neutral fuels, and electrolysis to produce hydrogen from water. The second area of discussion is elemental abundance. In regards to elemental matter, or physical mass, within the Recovery 2.0 system, we apply a methodology of maintaining a mass balance equilibrium, where 1 ton of input equals 1 ton of output. Waste materials processed may be regenerated within the system. Synthetic regeneration of elements or matter may be created by the human manipulation of natural fundamental processes. These elements may be converted in a controlled or an artificial environment, and may also be produced rapidly on demand, as opposed to a slower natural timeline. The evolution of technology allows us to refine elements back into their most basic form. You may use these basic elements as building blocks to produce any complex material such as industrial goods, chemicals, fuels, or any other commonly used materials. This can apply to any metal, mineral, chemical, or non-metallic element. As an example, items such as iron ores or bauxite can be refined into pure metals and minerals. The metals may then be fabricated into any product that you wish. Refined chemicals may be used to produce plastics and polymers, textiles and fibers, and many other industrial and household goods. An important fraction of elemental abundance applies to food. Food is fundamentally composed of chemical elements, primarily carbon, hydrogen, oxygen, and nitrogen, which combine to form nutrients like amino acids, proteins, fats, carbohydrates, sugars, and water. These elements may then be combined to synthesize foods using chemical processes or biotechnology methods. Before long, most of our food sources may come neither from animals nor plants. Synthetic foods may be built up from simple ingredients, industrially produced or grown in factories rather than in the bodies of animals. Starch will still be starch, fats will still be fats, but food is likely to become more abundant and cheaper with much less impact to the planet. Farming is likely to be replaced by synthesized food production processes such as brewing microbes through precision fermentation or artificial photosynthesis. Synthetic foods, sometimes referred to as artificial, cultured or synthesized food, aims to replicate the taste, texture, and nutritional value of traditional foods, offering a sustainable, scalable alternative as an abundant food supply. Within the Recovery 2.0 system, our goal is to convert waste materials, such as residual metals, minerals, chemicals, and foods, back into their basic elements, which may then be reintroduced into a regenerative loop to produce products, or for the generation of energy. The third area we explore is that of information abundance. Information or knowledge abundance refers to the idea of ubiquitous access to the collective accumulation of data or knowledge, readily available to anyone, from anywhere, at any time. This differs with past limitations or restrictions to knowledge and allows for a key shift in modern learning and predictive problem solving. The proliferation of sensors and switches in all of our devices and from all of our surroundings allows us to maintain a real-time awareness and the ability to perform instantaneous reactions. The combination of wireless communication and wireless energy transfer may unleash the astonishing potential of information and energy harvesting devices. What questions may arise from synthetic abundance? As we move from our current point in time, on the pathway towards the age of synthetic abundance, what milestones will we encounter? What are the challenges that we may face that result in a shift that may alter our way of individual life, or of society in general? Within the Recovery 2.0 process, we have focused a great deal of effort on energy recovery, in an effort to manage the energy continuum while attempting to maintain a balance or equilibrium with our environment. Historically, the access to inexpensive energy has been a major limiting factor in any industrial process, and subsequently has impacted the expansion of recycling efforts. With the advent of synthetic abundant energy and the maturing of technology, the recovery of waste resources may proliferate. This may allow us to achieve an unprecedented level of circular sustainability. We intend to discuss additional facets of synthetic abundance and the Recovery 2.0 strategy at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.